Okay, so this is the section on complex numbers, okay? So this is chapter 2 on complex numbers. Now the first thing that we got to realize is what is a complex number, or more appropriately, what is an imaginary number. Now imaginary number is just a system that was set up for a certain type of equation. So if you can see that these two equations here, x squared minus 1 equals 0. Okay, so what we can do here is bring the 1 over to the other side, we get x squared equals 1. Then we get x, when we bring it over to 2 over to the other side, it's going to be x is equal to the square root of 1, or 1 to the power of a half, depends what way we like to do it. Now there's two numbers that multiply by itself to give you 1. So there'll be two answers, x equals minus 1 or x equals plus 1. So we have two answers for this equation here. Now this equation here, however, has no answers as we know it. We bring over 1 and we get x squared equals minus 1. Once again we bring the squared over the other side and we square root minus 1. Now we know that there's no number in the world that when multiplied by itself gives you minus 1. So what mathematicians have invented was the letter I. So the answer to this question is I. Okay, so I is a letter that represents the square root of minus 1. Therefore, I squared is going to be root minus 1 by root minus 1. And what we know what happens when two square root signs multiply by each other, we get rid of the square root signs. In the same way that root 2 multiplied by root 2 equals 2. Or root x multiplied by root x equals x. Okay. So to overcome this, mathematicians invented a new number they defined as I. So that's I. Okay? So moving on quickly, what we have is integers of imaginary numbers. So the first thing to remember is that I equals the square root of minus 1. Therefore I squared equals root minus 1 by root minus 1, which equals minus 1. Next one, therefore, I3. Now I3, if you remember indices, okay, so the rules of indices is, let's say A2 multiplied by A3 is A5, A to the power 5. So what we're going to do here is we're going to break up 3 into I2 by I1, or I1 simply being I. Okay, and what happens here is we're going to get minus 1 times I, which ends up to be minus I. Next one is I4, and I4 can be broken up two ways. It can be broken up to I2 multiplied by I2, which is going to be minus 1 times minus 1, and minus 1 times minus 1 is going to be plus 1. Or we could have broken it up as I3 times I1, and I3 being minus I, and I1 being I. And then what you can say here is that there's a minus 1 here, so just multiply the i's by each other. I by I is I squared, and I squared is also minus 1, so you have minus 1 times minus 1, which equals plus 1. Okay, and that's the powers of I covered. Okay, now the next thing we're going to have is a complex number. A complex number has two parts, a real part and an imaginary part. So some examples here would be, let me see, 4 plus 3i is an example. Now this 4 plus 3i has a real part. The real part is the number 4, and the imaginary part is 3. It's not 3i. 3i, this is the imaginary number, right? But the imaginary part is 3. Okay, so likewise, if you have 2 minus 5i, the real part is 2, and the imaginary part is 5, or minus 5. Okay, or if we had minus 6 plus 0i, this is the same thing as minus 6. We say that the real number, or real part, is minus 6, and the imaginary part is 0. Remember, complex numbers always have a real part and an imaginary part, multiplied by I. Now, what we're going to do here is we're just going to loop a couple of questions here, and we're going to answer them. Okay, so we're going to go for number 3, 6, then maybe 11 and 12. Very easy, okay? So 3, 6, 11 and 12. Okay, so 3, 6, 11 and 12 are done like as follows. Okay, so the square root of minus 49. Now to do the square root of minus 49, what we do is we separate out the numbers. So for example, if I ever asked you what would be the square root of 12, what I can do here is I can pick any two numbers that multiply to give you 12. So an example would be root 3 multiplied by root 4, or another example might be root 6 multiplied by root 2. Now what you want to do is you want to make sure they're prime numbers, okay? Or you can get the square root of them. So for example, root 4 is 2, so the answer here is 2 root 3. This one here, we got to break up the 6 into root 3 times root 2 times another root 2. And root 2 times root 2 is 2. And once again, the answer is going to be 2 root 3. That's just a simple way to break up numbers, okay? So another way obviously would be, the first way would be obviously the calculator. Root 12 will give you 2 root 3. But it's good to know the other way. Now, with root 49, what we can do with all these ones is we can basically separate out root 49 by root minus 1. When you multiply the two of these, you get square root of minus 49. Root 49 is 7. Minus square root of minus 1 is I. So the answer here is 7i. Likewise, so this is question 3. Likewise, for question 6, we're writing the form AI. 7i is the answer. So for number 6, we're going to get the square root of minus 144 equals root 144 times root minus 1, and that gives me 12. Root 44 is 12, square root of minus 1 is 12i. Likewise for number 11, root 169 minus 169 is root 169 times root minus 1, which is going to be 13i, because square root of 169 is 13. Okay, and finally number 12, square root of minus 289 is going to be square root of 289 multiplied by minus 1, which is going to give me 17i. Okay guys, now what we're going to do next is we're going to try some of the other questions here, okay? So what we'll try here is maybe number 14, number 16 and number 18. Okay, now as discussed, this one's number 14. Okay, so what we're going to get is the square root of minus 12. Like last time, we're going to separate out into root 12 times root minus 1. We can go directly to the calculator, put in what is root 12 into the calculator, and root 12 is basically 2 root 3. So it's going to be 2 root 3 for the root 12, and this is going to be 2 root 3i. And you can see that this answer is in the form a root bi. A is 2, b is 3, I is I. And these two numbers have to be whole natural numbers, okay? And b is a prime number, and number 3 is a prime number. Okay? So another example of this will be number 16. What we can do is root minus 50. Once again, break it into root 50 times root minus 1. You put root 50 into the calculator if you want. Put root 50 into the calculator and we get 5 root 2. So it's going to be 5 root 2i. But if you didn't want to do that, you could break it up, root 50 into root 25 times root 2 times root minus 1. Root 25 is 5, 5 root 2, and then the I there. Okay, and finally we have number 18, which is going to be root minus 63. So what we get here is root 9, or sorry, root 63 times root minus 1, then break root 63 into root 9 by root 7 by root minus 1, and then root 9 is 3, so it's going to be 3 root 7, and the square root of minus 1 is the letter I. Okay. Okay, so to do the following questions, we got to remember this is questions 19 to 30 as an element of the set 1 minus I minus I. This basically means all the answers to these questions have to be 1 minus 1 I or minus I. Now what I'd like you to remember is this, okay, so if I had an example would be from the algebra last year, like x3 to the power of 4, the answer to this is x12. Okay, or if I wanted to do something else like x7, it could be x2 plus x5. Okay, so that's the sort of manipulation we're talking about here. Okay, now before we begin, we're just going to do the basic for again. So I I equals square root of minus 1. I squared equals minus 1. I3 is basically I2 plus I1, which is basically minus 1 times root minus 1, or minus 1i. Then finally I4 is the same thing as I2 by I2, or you could also call it I2 squared, and that is basically minus 1 squared, which is plus 1. Now that we've established what basically I1 to I4 is, what we can do next is we can figure out what some of these other ones are, like I6 and I7. Okay, so we'll try I6 here. So I6 is going to be, let's think of a way to do this. We could do two ways. I could do I2 by I4, and I could say I2 is minus 1, I4 is plus 1, and then minus 1 times plus 1 is going to be minus 1. Or I could also do I6 is basically I2 to the power 3, which is basically minus 1 to the power 3, and minus 1 to the power 3 is also minus 1. So there's two ways of doing the same question. Okay, next one I'm going to do is question 22, which is I13. So question 22, which is I13. And I13 is basically, I need to make a number out of this. So what I'm going to do here is I might do, let me see, I'm going to do I12 and I1. Okay, so I12 and I1. Then I'm going to work on I12. I12 is the same thing as I2 to the power 6, because 2 multiplied by 6 is 12, divided by I. Now what I need to do is minus 1 to the power 6 times I. And minus 1 to the power 6, if you put it into the calculator, please remember when you put it into the calculator, use your brackets. So you get minus 1 to the power 6 gives you minus 1. Look what happens when I remove the brackets. I get minus 1, which is the wrong answer. So please remember to put in your brackets when you're figuring out which one is which. Okay, so that's 1. Okay, so it's going to be 1 multiplied by I, which is 1i, and that's in this answer set here. Okay, next thing I'm going to do is I'm going to do question 26. Okay, so question 26. I to the power of 102. So what I'm thinking I should do here maybe is we'll try to go for, we'll divide 102 by 2. When we divide 102 by 2 we get 51, so I'm going to do I squared to the power of 51. I squared is minus 1, minus 1 to the power of 51. So I'm just going to change this 6 into a 51. Figure out what that is, and then we get minus 1. No problem whatsoever there. Okay. Now, I to the power of minus 3. Now this is an unusual one. I to the power of minus 3. Very hard to know what to do with this one. So we have to question 27. It's going to be I to the power of minus 3. Now to do I to the power of minus 3, what I could do is, so what you're going to find out about these ones is there's actually probably more than one way to do it, but what we're going to do is we're just going to use I1 minus I4. Okay, and then what I'm going to do is remember a rule about negative powers. X to the power minus 2 is 1 over x squared. Likewise 5 to the power minus 3 is 1 over 5 cubed. Therefore this is going to be I over I to the power 4. And we know that I to the power 4 is 1. So it's going to be just I divided by 1, which is I. Now another way of doing that would be to, even some people might have thought, well, why don't I just do I3 by I to the minus 1. Okay, and then what we'd get there is or I minus 3 is basically 1 over I3, and then I3 is minus I, so 1 over minus I. And people will obviously be thinking, well, this is the answer I got, and this is the answer I got here. Well, they're actually the same answer, but there's another chapter ahead that's called the conjugate chapter, and that will show you how to do questions like this, okay? So we won't do it just yet. Now, the next thing is I to the minus 20. I to the minus 20. Once again, what we can do is sort of a trick here. We might want to say, like, I don't know, I2, might go I2, oh yeah, we can go I minus 2 to the power of 10. And then we can, because minus 2 by 10 is minus 20, then I to the power minus 2 is 1 over I2, and I2 is minus 1. So 1 over minus 1 is minus 1. So it's going to be minus 1 to the power of 10. And minus 1 to the power of 10 equals plus 1. Okay. Okay, so the next one is question 31. Okay, in question 31 what we have is I to the power of 4n. Now I to the power of 4n is basically I4 to the power of n. We already know that I4 is plus 1. Plus 1 to the power of n. N has to be an even number. So it could be 1 to the power of 1, 1 to the power of 2, 1 to the power of 3. So n has to be a positive number greater than 0. So we always know that this will be the number 1 no matter what happens. Okay? The next one is part 2 is I to the 4n plus 1. Well, we break I to the 4n plus 1 into I to the 4n and I to the power of 1. We know that I to the power of 4n has to be 1. So this means the answer for this one is going to be 1i. Then the next one is going to be I to the 4n plus 2. Sorry. So next we're going to do I to the power 4n plus 2. And I to the power 4n plus 2, once again it's going to be I to the power 4n, I to the power 2. And then what we're going to get here is I to the 4n is 1. And then I to the power 2 is always minus 1. 1 times minus 1 is minus 1. And then finally I to the 4n plus 3. So I to the 4n plus 3. What we can get here is I to the 4n, I to the 3. We know that I to the 4n is 1. And we know that I to the 3 is minus I. So the answer is always going to be minus I. So there's our 4 answers for that question there, which is question 31. And moving on. Okay, so the next one is going to be number 32. Now in question 32, what we're just going to do is we're just going to do part 3. Okay, so we have 4i to the power of 3 minus 3i to the power of 6. Now remember, I3 is 4 times minus I, and I6, if I remember correctly, I6 is the same thing as I2 to the power of 3, which is minus 1 to the power of 3, which is minus 1. So we're going to get minus 3 times minus 1. And then what we're going to get is minus 4i plus 3, or 3 minus 4i. Getting the form a plus bi. And that's basically how we do these ones, okay? Or you could say 32 part 2 if you're really wondering. 32 part 2 is I30. And I30 is the same thing as I2 to the power of 15. And the next one is going to be 2i to the power 11. I to the power 11 is the same thing as I to the power 10, but I to the power 1. And then I to the power 2 is minus 1, so it's minus 1 to the power 15. Then I10 is the same thing as I2 to the power 5, which is the same thing as minus 1 to the power 5, sorry, that's a power of 5. Okay. So it's going to be minus 2 times minus 1 to the power of 5 times I. Then minus 1 to the power of 15 is minus 1 to my knowledge. So we just put this as 15. We get minus 1. And what about minus 1 to the power of 5? They're both minus 1s. Okay, so it's going to be minus 1 minus 2 times minus 1, because this here is minus 1, and then times I, and what we're going to get is minus 1 plus 2I. Okay, so there's question 32 done for you. Now, in question 33, write down the real part and the imaginary part of Z, where Z is the complex number. Well, it's quite easy really. We go 2 is real, I is imaginary, 5 is imaginary, minus 3 is the real part, minus 4 is the imaginary. Remember, it's not minus 4i, it's minus 4. Minus 7 is the real part, minus root 3 is the imaginary part, and finally 0 is the real part and minus 7 is the imaginary part. Okay, moving on to number 35. Now remember, complex numbers is very much like algebra. It's like addition and subtraction of numbers as well, so it's very much like x's and y's. So 2 times 2, 4, 2 times minus 3i is minus 6i, minus 3 times minus 2 is minus 6, then we have minus 3 times minus 7 is plus 21i, we get 4 minus 6, which is minus 2, then 6i plus 2, minus 6i plus 2i is minus 4i. Okay, so very easy there, okay? So now we're on number 37. Number 37 has a bit more multiplication in it. It's going to be 3 plus I into minus 2 minus 5i. Multiply it out like the double bracket, so we're going to get 3 times minus 2 minus 5i, and then it's going to be plus I into minus 2 minus 5i. Then multiply it out. 3 times minus 2 gives you minus 6. 3 times minus 5i is minus 15i. I times minus 2 is minus 2i. I times minus 5i is going to be minus 5i squared. Remember, the I squared represents minus 1. Minus 5 times minus 1 is plus 5. Okay, so now this whole thing here is now going to be a plus 5. Go up there. So what we have next is minus 6 plus 5 is minus 1, minus 15i minus 2i is minus 17i. Okay, now that we've done 37, we're now on 41. On 41, it's done like this: 4i into 2 minus 3i. Now we're going to get minus 2 minus 4i. Multiply it out. We're going to get 8i minus 12i squared. So 8i, so it's going to be 8i minus 12i squared. Close that bracket, and then multiply by minus 2 minus 4i. Remember, it's the same thing as like multiplying 2 by 3 by 4. 2 by 3 by 4 in the calculator is 24, so you can either multiply the 2 of these first, then multiply it by 4, or you can multiply the second 2 first and also get 24. So it doesn't matter which way you do it. Now this way we're going to multiply 8i. It's going to get multiplied by minus 2 minus 4i, and the minus 12i squared. Now remember, minus 12i squared is minus 12 times minus 1, which is plus 12. So we can get rid of that I squared business and put in plus 12 here. So we're going to get plus 12 times minus 2 minus 4i. Then we're going to multiply it out, and we should get minus 16i. It's going to be minus 32i squared, because I times I is I squared, and 8 times, so minus 32i squared is the same thing as minus 32 times minus 1. It's going to get me plus 32. So let's get rid of that. so plus 32. There we go, 12 times minus 2 is minus 24, 12 times minus 4i is minus 48i. Then we're going to get 32 minus 24 is 8, minus 16i minus 48i is minus 64i. So 8 minus 64i is the answer for that one. Okay, now we're on 43. Which looks to be a reasonably difficult question. So in 43 we can see that there is surds involved, so square root of 3 and whatnot. So what we have here is 1 plus root 3i, and then we have another 1 plus root 3i, because it's 1 plus root 3i squared minus square root of 3 into 1 minus root 3 minus root 3 plus 2i. Now we're going to multiply this out. It's going to be 1 into 1 plus root 3i. Then it's going to be plus root 3i into 1 plus root 3i. And then minus root 3 by minus root 3 is plus 3 when you multiply the two of them out. Then minus root 3 by plus 2i. So minus root 3 multiplied by 2i. You're going to multiply the 2 by the minus root 3 and you're going to get minus 2 root 3, and you're going to get the I behind that. So minus 2 root 3 I. Apply this out a bit more. We get 1 plus root 3i. Then we get another root 3i. And then we're going to get a root 3i multiplied by root 3i. It's going to be root 3 by root 3 is 3, I by I squared, 3 times minus 1 minus 3. Plus 3 minus 2 root 3i. Now look what happens here. The minus 3 cancels with the plus 3. Root 3i plus root 3i is 2 root 3i. That will cancel with the minus 2 root 3i, leaving an answer of 1. Okay. Now, if z1 is 5 minus 2i, z2 is 2 minus 3i, expressing the following a plus bi the following. Okay, so all I'm going to do is just do this one here, 45, and this one, maybe this one here. Okay, so iz1, I multiplied by z1, very easy. We're going to get 5i minus 2i squared. We know that I squared is minus 1. Minus 2 by minus 1 is going to be 5i plus 2. It's going to be 2 plus 5i. Very easy. Okay, so that's part 3. Now we're going to do part 4, which is I times z1 multiplied by z2. Now we already have the answer for iz1. The answer for iz1, this part here, is there's no brackets there, by the way, so it's iz1 of z2. So iz1 z2. So we already have the answer for iz1, which is 2 plus 5i. And this 2 plus 5i has to get multiplied by minus 2 minus 3i. Then we're going to put it all in. So we're going to get 2 times 2 is minus 4. 2 times 3i is minus 2 minus 6i, excuse me. And then 5i multiplied by minus 2 is minus 10i. Then 5i times minus 3i is minus 15i squared, which is plus 15. Then we're going to get minus 4 plus 15 is 11. Minus 6 minus 10 is minus 16i. 11 minus 16i. Okay, so what we have here is going to be numbers 47, 49, 52, 53. Okay, starting off with number 47. U is 1 plus I. So we need to find out what U cubed is. So it's going to be, what we're going to do is I'm just going to find out U is 1 plus I. U squared is going to be 1 plus I multiplied by 1 plus I. Multiply this out. And I'm going to get 1 plus I plus I plus I squared. I squared is minus 1. They cancel out. I get 2I. Then I have to find out what U cubed is. U cubed is the same thing as U squared multiplied by U1, which is, we know what U squared is. U squared is 2I, and we know that U is 1 plus I. Then I can find out what U cubed is, where I get 2I plus 2I squared, and we know that 2I squared is the same thing as 2 times minus 1, which is minus 2. So we get minus 2 plus 2I. Now I'm going to insert these answers into my equation. I'm asked to show that this thing here equals 0. So I needed U cubed and I needed U squared to figure this out. So U cubed is minus 2 plus 2I, and this is question 47. And then minus 4 times U squared, so it's going to be minus 4 times 2I. And then we have 6 times U, which is going to be 6 multiplied by 1 plus I. And then finally minus 4 at the end. Now to prove that this red sum all equals 0, so the minus 2 plus 2I stays the same. That's going to be minus 8I. This is going to be 6 plus 6I. And then that's going to be minus 4 equals 0. Now look at the real numbers. This is a real part, this is a real part, and this is a real part. The real parts are minus 2 plus 6, which is plus 4, minus 4 equals 0. The real part equals 0. Now what about the imaginary part? 2I minus 8I is minus 6I, then plus 6I gives you 0I. So we can see is that there's no real part, no imaginary part, and the answer is 0. And that's exactly what they asked me to prove, that it was equal to 0. Now, in question 49, we're looking for, and we want to find the value of k, element r. K is just a number, such that 2 plus I multiplied by k minus 5I is purely imaginary. Now, what purely imaginary means like this: a complex number. This is a complex number that has a real part and an imaginary part. If it's purely imaginary, it means that the real part equals 0. So for example, 3I is a purely imaginary number. If it's the opposite way around, where we're asking is a real number, well, if it's real, what we can say is that the imaginary part has to be 0I. So it'll be 2 plus 0I, the number 2 is real. So 3I is purely imaginary if it's on its own, and 2 is purely real if the number is on its own. This one here has both real and imaginary numbers. So let's begin with this one here, 49. We're going to multiply it out. So we're going to get 2 times k minus, so was it 2 times k minus 5I plus I times k minus 5I. Now please remember that the real part has to be equal to 0. So we're going to get 2k minus 10I, then we're going to get ki minus 5I squared. Minus 5I squared is minus 5 times minus 1, which is plus 5. That, okay. Now we look at the real part. Just the real part here, the real part here. This means that 2k plus 5 has to equal 0, because the real part has to equal 0. So what this means is that 2k equals minus 5, k equals minus 5 over 2. Hence the element r part. The element r part means that decimals and fractions are allowed in. So it complies with that answer. If it was element n, this wouldn't be allowed because it's a negative number and a fraction. Okay? So that's that part done there. So what we're going to do next is we're going to be looking at question 52. Okay, so question 52. Given that z equals minus 2 plus root 5I, find the real number k such that z squared minus k times z plus root 5i is real or purely imaginary. So what I'm going to do is I'm going to write down z, and now I'm going to figure out what z squared is. Z squared is minus 5 plus root 5i, then minus 1 plus root 5i, multiply it out. Minus 1 times minus 1 plus 1, then minus 1 times 5i minus root 5i. Sorry, square root sign looks a lot like number 5. Root 5i. And then it's going to be root 5 times minus 1, which is minus root 5i. And then root 5i by root 5i is going to be 5i squared. 5i squared is minus 5. And then what we're going to get is minus 4 minus 2 root 5i. Now we're going to put these numbers into this equation here. Z squared is minus 4 minus 2 root 5i. Kz is going to be minus k times what z is. Z is minus 1 plus root 5i, and then we have a root 5i at the end. I'm going to multiply this out. So I'm going to multiply this out here, and what we get is minus 4 minus 2 root 5i plus k minus root 5i plus root 5i. Now the root 5i's cancel off, and what we're going to be left with is k minus 4 and then minus 2 root 5i. So we're missing something here. Oh, sorry, my bad. It's getting multiplied by k, so that can't disappear. Excuse me. So that's going to be root 5 ki, or we can call it k root 5. K root 5 I plus root 5 I. Excuse me. So we're going to get k minus 4, and then in the imaginary part we're going to have minus 2 root 5i plus root 5i gives us minus root 5i. And then we also have minus k root 5i. So we have the real part, which is k minus 4, and then we have the imaginary part, which is minus k root 5i, and then minus root 5i. Now, in the first part it says, so the number is real. If the number is real, the imaginary part equals 0. So minus k root 5i, oh sorry, the imaginary part equals 0, so minus 5i equals 0i. It doesn't exist, so the i's cancel, and that's a root 5, excuse me. So what we have here is minus k root 5 minus root 5 equals 0. Bring the root 5 over the other side, and we get minus k root 5 equals root 5. Cancel off the root 5s off both sides, we get minus k equals 1. K equals minus 1. K equals minus 1 is the correct answer. And next we have purely imaginary. Now, if it's purely imaginary, this means that the real number equals 0. So that means that k minus 4 equals 0. Bring it over, and then k equals 4. Okay guys, now finally what we have next is if Z1 and Z2 are complex numbers, solve these simultaneous equations. So what I'm going to do to make these look more like a normal question, what we're used to, I'm going to say let Z1 be x and Z2 be y. So I'm going to get 2x plus y equals 5, and I'm also going to get x plus y equals 4 minus I. I'm just going to multiply the bottom one by minus 1, so I'm going to get 2x plus y equals 5, and then I'm going to get minus x minus y equals minus 4 plus I, And then what we're going to get is x equals 5 minus 4, which is 1. X equals 1 plus I. So z1 is 1 plus I. Now we have to figure out what z2 is. Okay, so to figure out what z2 is, we can just input into this equation here. So we have x is 1 plus I. Replace the x, add on y. That equals 4 minus I. Bring the I over, bring the 1 over, and we're going to get y equals 4 minus 1 minus I minus another I, and what we're going to get is y equals 3 minus 2i. Okay, and that's the end of this exercise here.